Welcome to our video on geoengineering, a solution or a dangerous gamble against climate change. Today, we're diving deep into the controversial world of geoengineering, exploring its various techniques, from solar radiation management to carbon dioxide removal. As the climate crisis intensifies, will these technological innovations offer a viable solution or lead us down a perilous path? Join us as we examine the potential benefits, risks, and ethical considerations surrounding this bold approach to combating climate change. 1. What is geoengineering? Geoengineering is essentially about making substantial changes to the Earth's systems to mitigate climate change. It is divided into two main categories: solar radiation management, SRM, and carbon dioxide removal, CDR. SRM seeks to reflect sunlight away from the Earth to reduce temperatures. In contrast, CDR focuses on removing carbon dioxide from the atmosphere. These methods aim to address the root causes of climate change, but their large-scale nature raises questions about their feasibility and safety. 2. Solar radiation management, SRM, techniques. SRM involves several innovative techniques designed to reflect solar energy away from the planet. Stratospheric aerosol injection, SI, is one such method, which involves releasing reflective particles high into the atmosphere. Another technique, marine cloud brightening, aims to increase cloud reflectivity by spraying seawater. Space reflectors offer a more futuristic approach, involving mirrors placed in space to redirect sunlight. Each technique holds promise but comes with its own set of challenges and uncertainties. 3. Carbon dioxide removal, CDR, technique. CDR methods focus on reducing atmospheric carbon dioxide levels. Direct air capture involves machines that extract carbon dioxide directly from the air. Afforestation and reforestation, on the other hand, use nature's own methods by planting trees to absorb carbon dioxide. Ocean fertilization seeks to enhance phytoplankton growth by adding nutrients to the oceans, which in turn absorbs more carbon dioxide. While these methods sound promising, their implementation and effectiveness remain under scrutiny. 4. Potential benefits of geoengineering. Geoengineering offers several potential benefits in the fight against climate change. SRM could rapidly reduce global temperatures, providing a short-term cooling effect. CDR methods could contribute to long-term climate stabilization by achieving carbon neutrality. Furthermore, these techniques might delay the more severe impacts of climate change, giving humanity more time to transition to sustainable energy sources and reduce emissions. 5. Risks and uncertainties. Despite its potential, geoengineering carries significant risks and uncertainties. SRM techniques could unintentionally disrupt weather patterns, leading to adverse effects on ecosystems and human populations. There's also the moral hazard of relying on geoengineering, which might reduce the urgency to cut greenhouse gas emissions. Additionally, the regional impacts of geoengineering could vary, benefiting some areas while harming others, raising concerns about inequity. 6. Technological feasibility. The feasibility of geoengineering varies across different techniques. While some CDR methods, like afforestation, are well established, others, such as direct air capture, are still in the experimental stage. SRM techniques, meanwhile, remain speculative and controversial due to their potential risks. The technological challenges involved in implementing these methods on a large scale cannot be underestimated. 7. Cost comparison. When it comes to costs, SRM is relatively inexpensive compared to other climate change solutions. However, it doesn't address the root cause of climate change, which is greenhouse gas emissions. On the other hand, CDR methods, while more expensive, tackle the core issue but require significant energy inputs. The financial implications of geoengineering must be carefully considered alongside its potential benefits and risks. 8. Regulatory and ethical challenges. Geoengineering presents unique regulatory and ethical challenges. Currently, there is no comprehensive global framework to govern its implementation. Ethical dilemmas arise over who gets to decide when and how geoengineering is used, and what happens if these interventions cause harm to vulnerable populations. The lack of regulation and ethical considerations make geoengineering a contentious issue that requires careful thought. 9. Public perception. Public perception of geoengineering is mixed, with skepticism and resistance being common responses. Given its experimental nature and potential risks, gaining public trust is crucial. Transparency and public engagement are vital to ensuring that any geoengineering efforts are legitimate and accountable. Without public support, the path forward for geoengineering remains uncertain. 10. Complementary or standalone solution? While geoengineering offers potential solutions, most experts agree it should complement, not replace, emission reduction efforts. Relying solely on geoengineering is seen as a dangerous gamble due to its uncertainties. It's essential to view geoengineering as part of a broader strategy to combat climate change, rather than a standalone solution.